Okay, it looks we are live. Stream was scheduled for yesterday, but there was surprise with fiber optic cable. So actually, what was not working yesterday was that piece. So today, technicians with welder and some fiber optic cables check tools check that well. There is great red light out of this wire, so yeah, I have the broken one, and I hope that the current speed of network is maybe better even. The agenda for this stream is like that, so it will take about half hour up to 1 hour, but I hope less. The topics are again SIMD programming, a bit different examples, but still simple. Some vector extensions that are also very useful to process data. There will be some additional informations to check over internet, and as a bonus there will be some helpful tools in case that to build some intuition on trigonometry functions, cosine and sine. Also simple, but with some additional and yeah, lastly we had issue with libraries, and sorry, that's not that one. I will open new window and I will select the folder, so it will be stream number 2. Yeah. So it's starting point again. So currently, yeah, there will be some additional features of Cmake as well. So let's also open the terminal. We have the terminal, and we start with folder for Intrinsics, and it will be built as a library, static library, that will be attached to by linker and compiled together, actually linked to utilize the function that we keep there. So we have that. In this we create the include, and also there we create source catalog, and we create additional SRC folder, and yeah, so we have the basic structure. So we need to create in our project, we'll create new file which is cmake lists.txt, and the same I will copy and I will paste in our library. So that's the starting point. So we have that, and in the includes I will create header.h. That's as simple as that, and there is add. So it might be more than half an hour. Okay. So the scope, there is interface public and private, and I think there are some informations about the scope. So if you go to the scope, so you will get information about how each of those scopes works. Okay, so actually for building and for using the target, it's public. For just building is private. For just using is interface. So you can experiment and make those changes. So actually I will provide the public and our include catalog. Include. Okay, so we have yeah, that's very simple, and that's it actually. We will check that later. So again, as previously, let's create a not defined h.intrinsics h or like that. Define copy and if, and that will be what we will use there. So let's actually build 3 functions. So void f1 and same way f2 and f3, f2 and f3. So that will be again declaration of functions. I hope we are live. Let me check. Okay, the screen change. Okay, and then probably we need to prepare Visual Force Studio to use those includes, but include so Intrinsics, it's not there, so Control Shift P is to open JSON, and in JSON configuration we need to put information about our includes. Intrinsics / include, and then okay, so let's keep the names as previously. What is the name of it? Will start to act Intrinsics. Okay, and then so yeah, this is very simple. So you create with add library, you tell what sources should be there, what include path, and in main CPP you are just adding subdirectory for build, and it will compile dependency library firstly, and then your target. So then we need to have int main return 0. if I put include, no, just let's see what we'll tell when we compile it. So second thing is add executable, and that will be name of our application and src main.cpp. We need to create folder, build, when we build it, and the same as previously, we use Cmake. And it looks, it compile, we have Intrinsics, it prepares, sorry. To compile we need to Intrinsics header, not file or directory. Okay. Intrinsics include header. If you call Make again, no, the problem is still there. Include header. That's not what I wanted, actually. Okay, if I will put include there, some lesson learned, and some topics to investigate how Cmake works actually. Yeah, but we are doing engineering, so we connect multiple things, different shapes, not just one shape. We'll work on on it later. Sorry, I use phone. Okay, so we have the functions are empty currently, and well, actually we know what we need to do with them. So the first working example, again we need to use attribute, and then we need to specify target in additional brackets, and that will be as before AX512BW. Yeah, actually I was stressed before on before stream, and instead of LSCPU I use PCI, which gives some informations about the the computer, but for CPU online there is LSCPU. So actually it's mainly same what catprocs info shows. So yeah, the flags for instructions, SSE, and somewhere there VX, and yeah, there is one more important part and one more page, Intel Intrinsics guide. Yeah, so this is instruction set guide when you can check the functions, the pseudocode that it realizes, and what instructions, and sometimes it uses sequences, so it's not optimized. So it's good to to check this Intel Intrinsics guide for you to know. You have also the categories that you can check, and as I mentioned, we will check some trigonometry, and for example they use sequence operations, so it's the performance is not as good as the regular functions. Let's say some arithmetic. Let's use some what we're using, 512, some multiply, precision double, precision single, and the latency is important. So this is latency of how many instructions it takes, sorry, cycles, and the instruction, how many cycles of the CPU it uses, and there is a split over the architecture. So there is Skylake, Ice Lake, and so on for desktop, for server, and I think the new one that is coming is Nova Lake. And yeah, there are some Raptor Lake and more lakes actually. So you can check the architectures, and there is, I don't know how many functions, but you can scroll half a day and spend some months on that. I haven't done it yet, but it's very interesting, and there are some cryptographic functions that speed up also the calculations. If you work on that, probably it's very good to check, because that's different of nanoseconds sometimes, or milliseconds. Actually, it takes nanoseconds for some operation. I haven't checked cryptographic, but we will try to figure out that really instructions takes nanoseconds. We'll not be comparing here, because it will take whole day to talk about that. So you can we will go to that part. I will keep this screen, and maybe I will open again. It's F, not BW. So if we go to F, we will have it. Okay. Oh, and another part I found, VNNI. So it's vector neural network instructions. So I don't have it, but you can check. Some VNNI advanced vector extensions, and if we find on the page, how to find something here. How to find on Firefox VNNI. Find in page control. Where is find in page? Ah, it's at the bottom. VNI. Okay, let's go to that page. Alder Lake. So 2021 it was introduced. Vector neural network instructions. You can check about that for AI and related topics to machine learning to boost operations. VNI, and since 2021 that should be a good spot. Okay. Question if we have for 512 bits, which is 64 bytes. Yeah, we have that. Okay, let's go back to coding. Let's go back to coding. So this is FAOX 512BW. We can check with F. If not, I will make note that it will be BW. Second one, we use just 32 bytes. And that will be AVX2. What's wrong? 3-bit. And second one, we also use 32. So we will make that. It's already almost half hour. Okay. It will be recorded. Okay, so we have include. You can see. And if I will use just that. Okay, let's see. If not, you can use the absolute path. This is just related to the workspace. Okay, so over there, what was not working also? The standard cout, so console out. And I've checked that Visual Studio Code was not loaded the same as currently. So let's see. And let's just check some information about the threads. Hardware concurrency, and we'll use standard thread hardware concurrency. Simple part. Let's make it. Let's run it. Okay, so we have all 8 threads. So also that depends on your CPU. So not just the instruction sets, but also how many cores you can use concurrently. So I have 8 cores, and I don't have VNI instructions. Okay, so this is working, and to not switch too much. Okay. let's just jump. Delete all. What trigonometry we have? We have 512 ACOS, which is arcus cosine. So from cosine you can get the angle actually, and this is for f as well. Okay, I was not trying that, but let's check that actually live. So it should work, and include IMM intrinsics. So that we will use in the intrinsics, and we need to configure project. And I left that that line because to configure the compiler that you want to use, you need to specify that before the project function. So you need to set Cmake 66 compiler and ICX it will be. And as you saw where it was, and the GNU compiler G++ was used, but if we set ICX, I need to delete again the configuration, so we need to know that it keeps the configuration. And with that compiler set, you see that it switched to Intel, so you don't need to specify dynamic options Cmake 6 compiler to ICX, but you can keep it in the project configuration. Okay, so we just use main currently. We haven't used intrinsics, so to use the library target link libraries for our executable, we can specify it private, and it will be what it will be, my intrinsics. That's the name. And again we've got that. I will close window, I will open again, and somehow it keeps problem. But currently it loads. So I'm not sure what is blocking the window or the system. Again, extra path from command line. Oh, dear. So we need to use again printf, undefined reference. strange. But okay, we'll live with that. And I'm not sure. I'm not sure why that happens again. Because to be honest, it shouldn't. Okay. Okay. So there we need to include intrinsics, no suggestions. So if I will use just header, okay, that's strange. Okay, and let's just simply F1. Okay, so that's F1, F2, oh, F2, F3. To specify there is to set the flags. Set Cmake CX6 flags, and that will be optimization, architecture native. Trash. That was not the purpose. Don't need to be ninja. Cmake, and sorry, and build. Cmake, make, all three unknown. Okay, so we need to. Oh, that's 0. Oh, sorry. Optimization, not 0.3 but 0.3. Okay, again, very simple, and there. Okay, so maybe let's make just 2 of them. We don't need 3 functions, because there will be one more topic, and that will be too much at once, I would say. Okay, and I will show you later a funny thing about standard cout. On the project I was preparing that stream, I was studying and checking the options, making, breaking, and so on and so on. Okay, so for that one, we'll implement first that one, or maybe I will delete that as well. So that will be straight to the point, because we just use new instruction, and the simple one for 32 bytes, 256 bits. So we have M256, and that will be angles, and you can instantiate that with initializer list in C style fashion. So let's say for 0 angle, 30 angle, 45 angle, 60 angle, 90 angle, 180, and then plus 92, 70, and 360, which again is 0, so we are doing the round. So we have angles, and we specify also the conversion, because the functions there use radians, and there is simple conversion between angles and radians. So I will show that, and we use n to 560 set 1 ps, and for that we use we include Cmake. We will use conversion, which is m. So this is the number pi over 180, because pi is pi radians. Radians is 180 degrees, and we need to, so radians. So that's the radians. Okay, let's call it radian conversion. And we just need to simplify angles with that number. So we also use m256. It will be radians, which is mm256 mil precision single, and that will be angles and radian conversion. Okay, so we have radians, and now we will calculate the cosine. M256 result is mm256, so cosine, precision single, and we use radians. So for our angles, so why is undefined? That's strange. Make F2. Okay. We don't need F2 now. Some issues. After the call, it will work. I believe it will. Okay, so now it's not the trick, but you can use simply the subscript to get the information about the cosine. So we have that. So this is the vector of of length 32 bytes of float, so we can use size of, we can use 8 because we have 8 values. We know that it's 8, but we can use the conversion. Size of float, and we will update the index, and we will we have that IO stream for printf. see out again make problems. Okay, we just show two numbers after for the precision, and we use result from I. Maybe 2 spaces. How about now? Okay, we go from 1 to 0. You know how it works, yeah? From on 0, on the start point, it is 1, so we're going down to 0, then we go to, because we taking 90-degree in addition of degrees, so we have from -1 again to 0 and again to 1. I will make a chart as a bonus how to memorize and quickly learn and understand the cosine and sine and those things. So it will be good to exercise that actually, and plot. You can plot after that yourself, and yeah, have the muscle memory and some visual memory and the practice to understand it better. So you see it shows issue, but I've ignored that. It shows again wired. Okay, and after that let's print just new line, and let me just check. Okay, it looks better. So you can relate angles to the cosine values, and you have conversion from angles to radians, and actually to convert it vice versa from radians to angles, you need the radian multiplied by the inverse, so 180 over pi, and then you will get actually maybe let's plot that now. Online plot paint. Will it work? Okay, it works. All right. So let's. It will be kind of some polar chart. You have to check actually, but yeah, we have a circle. We have our x, which is not x, and our y, which is not y. Let me just, where is text? So that is cosine. That is sine. Okay. And okay. I will plot here. So we start over here from that point. This is our 0 degrees, okay? And over there we are going, we have from math we are going left, we have first quarter, we have second, we have third, we have fourth. So 0 is also 360 degree. This is 360. So if this is 360, so this is 180. So this is 90. If this is 180 and this is 90, so this is 180 plus 90, which is 270 degree and 360. And 0 is 0. 90 is pi over 2. If this is pi over 2, so this is the pi. This is pi plus pi over 2, so 3 over 2 pi, and 0 is 0, but also it will be 2 pi. It's same, and the function is it's same, so it's like going through the circle. And if this is cosine information, so one important thing I haven't mentioned, the radius, so that part is 1. And if this is 1, you can simply understand, I will write it like that. So we have cosine start there, this is 0, so for 0 we have exactly 1, and for sine we have 0, so sine start like that. Okay, so it's not cancelled out completely like that for rather for continuous signals, because it's just 90 degree in phase, not 180, so it cancel in half, let's say. But we can use the sine for alternate current, which is also very useful for radio frequency carrier, which is also from the alternate current, and we can create some stream with some programming, I believe, but later. So we have 0 here, we have 0, we have pi over 2, we have pi, so again the cosine will be exactly 1, and we will go there, so we have pi 3 pi over 2, and we have then 2 pi. No, it's I've missed something, I think. Here is 2 pi. No. Pi over 2 pi 360, 2 pi is there, so we completely don't need maybe I will how to remove that. Can I remove that and delete? Okay. I will provide it again. So we have our x, we have our y, we have y. Okay, so we have 0. We have, there is pi over 2. There is pi. There is 3 over 2 pi. And there is 2 pi. Okay, so this is one cycle, and that's the other cycle, so we really don't need that. So we have full cycle, and again that is 0. Okay, something like that. And this is 1. That's the maximum. It should be equal, yeah, but it's not. You can make it better. And there is, so there is 1. This is minus 1, like that. So if we go from here, we go 45 degree, okay. So this is important, because the projection on cosine and on sine will give you the value. So 45 degree, it is like something about above the half, yes, and 45 degree for sine is also more than half. So the projection of that value this is our radius. We are going through the circle. In math, you are going left, so you are going always left, like that. So the projection on the cosine axis, on the sine axis, gives you the value. That's why for pi over 2, the projection on the cosine is 0, and you see that it approached the 0. So the slope is going over the 0, and the cosine maximum is again, but this is the minus 1. So here we have pluses on that side. On that side we have minus. So then you have minus 1, and same you have plus 1, and then you have minus 1. So we have 1/2. We have 2 halves actually. Right hand side is plus, left hand side is minus. Upper side is plus, lower side is minus. So the same if we go, if you have projection on, let's say, okay, simple. We have 270 degrees. So again, 270, which is 3 over 2 pi, is 0 on the cosine, but is minus 1 for the sine. So this is sine. Cosine goes half over the y-axis. This is the y. Okay. Oh, that was 1 hour. but we can continue actually. Maybe with coding. I had some other ideas as well regarding the circles, and maybe one important part is what is that pi actually. So this is the proportion, and if we have our circle and we have the radius, which is that one, okay, this is the radius, and we know that okay, this is our diameter. Let me quickly check. Translate. I forgot one thing. Circumference. Sorry. sorry. Circumference. So what is the circumference? So this is the circumference. Yeah, it should be on the circle, and the relation between the radius or diameter and circumference, we know that circumference is 2 pi r. So this is our radius, and it actually be 2 pi 2 r. 2r is our diameter, and if we will take diameter and we will lay on our circle, it will take 3,14 and so on and so on. So you need 3,14, so the pi of diameters to take the circumference. Yeah, so we have 2 pi r, which is pi 2r actually. So this is the pi over there, and yeah, that's good mnemonic actually, to know what is the pi. It is the circumference, the ratio of diameter to the circumference. It is the pi, so that's why it's there, and we have pi r square. We will not be going into that because that needs integrations, but derivative of pi r2, we have pi is constant, of course, so we take that, and we have r2 is going there, so we have 2, and r have 2 minus 1. This is the definition of simple function in the difference. So the area, so actually the circumference is derivative of the area, but to take the information, need to integrate a lot of and yeah, I'm not so clever to be mathematician, but maybe when there will be some programming for that, we will also learn it. Okay, so that was the bonus actually, and if you have time, we'll go back to our calculations, because I wanted to show another simple thing. So we have that example, but it is good also to know a bit, of course not everything, but to know vector extensions. I will write directly here. So you can define the vectorized array with the construct from simple is from C. So type def, you define your new type, and you say it contains int, so vsi, this is the name, and you need to provide similar thing as it was there. So I will just copy, float. Okay, so we have our type, so it is also 32, but let's make it, let's say 16. So 16 bytes equal 180, because float has 4, is single precision, double has 8 bytes, float has 4, so 16 sorry, that will be 4, so it will be 64 bits. 16 times 4 is 64, yes, so 32 is 180. So we have allocation, and yeah, what is the allocation? We have allocation of 42 bits, 16 bytes, because we use float. If we use double, so that will be 8. So we will have just 2 numbers, and then here we have 4 numbers. And also important for working with Intrinsics is memory alignment, and I will show how to use it in C. Attribute, you have align, and you have 16. So you are telling that the blocks should be aligned in memory, in contiguous memory, on 16 bytes, and that speeds up the functions. So also when you work with Intrinsics there, and let's say you have array of floats, array, let's say it will be 8, that will be that. Okay, so in C++ you use align as 32. You are using align as, and then you can set also. Let's try it as well. I will comment out that part. I will put there. I will use that, and then I will use an array. Actually, array. What we need to use 0 there. It's give me a second. Okay, let's try to compile that. Set 1, we need to use load. Okay, you can load with float. Yeah, another important part. So vector instructions have concepts of gather and scatter. So when you load, you gather. So you have separate values, but you want to load to your type, which is aligned with registers. So that's why this align as is there, because it ensures that your memory alignment will is exactly what register expects. So that is boosting the operations as well. If the alignment is proper, and actually linker doesn't need to do any additional changes. Yeah, so load, it has pointer, and that was the problem. This is the pointer, but yeah, it loads the 8 bytes we have there. And if you go back to our vector extensions that you can You can Google on GCC vector extensions, and there are examples as well. I'm just providing some details. That's quite long, actually. Okay. And what we can test now. So we have our type for SI, and you need to prepare your vector. File1, let's say it's the name, and it will be file2. And you can use simple operations, like you can to file1 to each value add 1. So actually that operation is vectorized, and file2 will be 1, 2, 3, 4. Okay, and the same you can use with for SI file3. Equals again file1 times file2, and we can print that again using a subscript. So we have size of file SI divided by size of float, and we have I plus plus, and we can try cout of file3 of I, and we will add space, and at the end standard end line. How it works. That's strange. Again. So expect, actually we don't have anything in the decimal position, but okay, let's leave it. And just print new line. Make. Ooh, I'm sorry. What's happened there? Oh, unlimited loop. Interesting. Let's say make. Okay, so we have the calculations. We see that it's 0. So if we multiply by 0, we have 0, but then we go to 2, 6 and 12. So 3 times 4 is 12. 2 times 3 is 6. That was the one of the ways. So the subscript is actually the easiest, but you can have some additional informations in the containers. For example, contiguous vector, which is often used, and there is one way to use your results. So we have float, and we want to create we want to have pointer from our vector. So for that we use reinterpret cast, and for that we are telling that we want to have our pointer, and we are passing the pointer to our v3. Oh, it's not int. Okay, and then I will use same, but for that we use res. Let's compile that. Okay, it works, and the tiered version not very useful, but you want to have alias, so you are telling that you want, maybe for vectors it might be useful, but to have the alias you need to have the pointer there. So we have pointer res2 plus the subscript, means the position that you want to switch, and it takes the number of bytes declared for your type. So if it's double, it will switch over 8 bytes. For floats, it will switch over 4. Oh, I need to have so I need to take value from our pointer. Not +1, plus I. Okay. Yeah, that's, I would say that's done. You can try with the pi. So the word pi is actually 2 pi in maths. So if you have apple pie, you will know that it takes 2 pi, and yeah, the pi is proportion of 2 radius, which is really which is the diameter. So this is the number of diameters it takes to lay out on the circumference. And yeah, what I want to show also is C++ reference, where are the informations about the C++, the methods, standard libraries, and what's in. I almost finished, and C++ 26. This is not released yet, but you see that C++ 26 have SIMD instructions, and that will be the new standard, and a lot of interesting parts, like to work with the vector data, because there is a lot of data everywhere. So to utilize also the CPUs the best. So they have a plan actually to implement that in the standard. That's very interesting. Okay, thank you, and